All right. In this lecture, we try to implement multiple regression in SPSS. First of all, what is difference between simple regression and multiple regression? Given linear regression, simple linear regression or simple regression, we only have a one independent variable, right? So x1 if impact onto y, which is dependent variable. But right now we have a two independent variables. So this is a simplest version of multiple regression, right? Because we have a two independent variable. You know what? There's a several research question associated with this multiple regression idea. But first of all, first research question is, what is my regression equation, like a regression model, whether my regression model is statistically significant or not, or explaining well how dependent variables are varying or not. Overall model assessment, right? That's number one. Number two, whether those intercept or slopes associated to x1, especially slope associated to x1, the first independent variable, is statistically significant or not. And then also at the same time, we are evaluating the slope of x2, the second independent variable, is statistically significant or not, right? Like for example, this particular slope is different from whether you have it additional independent variable or not, and interpretation of this slope with x2, without x2 is very important, right? So we will play around those, how to implement this particular regression model. Very simple, only two independent variable in SPSS together. Right. First of all, SPSS. There's a four independent variable in here, potential independent variable in here, and we had the dependent variable, which is y. Analyze, regression analysis, linear regression, right? Still we have an dependent variable as a y, right? And the next step is we had this first independent variable, like for example, click both of them like this, send it in here, and then we will evaluate those x1 and x2 as an independent variable and the y as dependent variable as it is. Very easy. Why? Please. Regression analysis and traditional regression analysis, conventional regression analysis is univariate analysis, only one dependent variable. You can have as many as independent variable in here. By default option to the how to entering those things, right, is like enter option, right, the first block. And we will talk about those blocks. And we will talk about those, other method to including independent variable, later. Okay, let me just go ahead to click OK, see what's going on. You click OK, and we able to see this result. Number one, descriptive statistic, cool. Correlation among x, y, x1, x2, cool. This is correlation analysis. We learned it before, right? And how those models are entered and how many different type of models. We only have one model, and given dependent variable y, we enter both independent variable x1 and x2 at the same time. This is how we interpret this part, right? Because right now it's kind of boring because this is default option, but this part getting more excited if we move on to another part. Model summary. All right, model summary. And then R is what? Square root of our square value. Our score is 0.31, which is what? Nearly around 31%. 31% of the variability explained by or accounted for by this model. What is that model? Using these two independent variables. So it's nice to understanding what model we are referring to, right? This model is different from simple linear regression model. We ran it before. Why? Because in this particular case, we entered both independent variable. So we have a two independent variable, right? as a diagram. So we did it in, we are referring this model, right? Okay, and move on. How about this? An ANOVA table, right? Regression, sum of square regression, sum of square residual, sum of square total, exactly same thing. But we have a different degree of freedom in here compared to simple linear regression. Why? Because in this case, with degree of freedom is 2, which means what? Why this is 2? Because we entered 2 independent variables. That's the reason why we have a 2 degree of freedom. Another residual degree of freedom total is exactly same as before analysis variance concept and simple linear regression concept, right? And overall, what happened? This is what? F observed value, and this is statistical significance of overall regression model is very, very statistically significant, and this value is very small, even way smaller than 0.01, right? My alpha value. I mean, the whatever researchers alpha, lowest alpha value conventional choice. This is very, very small, so this is statistically significant. Coefficient. Let's go over coefficient part. Again, what is constant? Constant in SPSS, this is a slope, right? So B sub 0 is 30. How to interpret this slope? I mean intercept, I'm sorry. Constant in SPSS is intercept. How to interpret this intercept value, B sub 0 value? Both x1 and x2 is a 0, right? And then you will have a what? The model expected value of y will be 30. Let's put in some context. Let's say your dependent variable is educational achievement, like SAT, SOL score, right? A standardized learning outcome score, right? X1 is how much they're learning it, right? X2 is their for example, how anxiety, test anxiety, right? So interpretation of this study is if a student 0 in X1, no study at all, and 0 in X2, which is a 0, like for example test anxiety, and that student expected to have what learning outcome will be 30.460. This is how we interpret this slope value. What is this this intercept value? I keep confusing myself. This is intercept value, right? How we interpret this 0.104 as a slope? If we consider this x1 as what? How many hours they study, right? If they study 1 more hour, and the learning outcome will be expected to increase. Why? This is positive 0.104, right? This much. So if they spend 10 hours of study, then we got a what? 1.04, like approximately 1 score higher up onto assessment, given dependent variable, right? So etc. So you can interpret those intercept and slope value as it is. Again, standard error associate intercept and 2 slopes, right? And then also standardized coefficient beta value associate each slope. Why this is nothing in here? Because if you standardize everything, and intercept will be 0 anyway. So 0. Technically this is a 0. And also what? This is standardized slope for x1. This is a standardized slope for x2. T observed value to test whether this slope is statistically significant or not, right? And sig value or p-value, you will see what? x1 p-value is 0.251, which is way greater than conventional 0.1, 0.05, and 0.01, right? So I would say x1 is what? Not statistically significant. And x2 is statistically significant. But be careful. This statistical significance is what? Is at the same when you're including this x2, right? Whether you have it x2 or not, and that this statistical significance may differ. So be careful, right? So how we interpret those intercept slope value? This is slope, x1 slope when after control for x2. How you interpret this x2 value? Well, This is a slope, x2 slope, when after control for x1 or vice versa. Statistical significance as well. How you interpret this? Well, x1 is not statistically significant in this model with after control for x2. Same thing. x2 is statistically significant in this model after control for x1. Are you with me? That is key difference between simple linear regression to multiple regression, how to interpret those slope value and statistical significance, and also overall model summary. Thank you.